Yeah, mom.
All right. So just tell me one thing. What all did you write in the last class? Till here, did you complete the writing part? Huh? The writing was done or left?
We wrote, ma'am.
You've written? Okay. So let's complete this. See, this says calculate acceleration of each and acceleration of the center of mass. So acceleration of each can be calculated using the concept of the laws of motion which we have studied, tension, free body diagram and everything. Right. See, this is 5 kg body. Here tension will be there. Downwards 50 will act, right? 5g. In fact, I'll write it as 5g. This is tension and downwards 10g will act. Now see, what did we discuss? When we'll have this is I think this all of you have done. Who all are here today? Mariam is there, Nabiha, Saniti, Tahura. Till acceleration part, at least you all should be able to tell. Yes, Mariam, let's start with you. Free body diagram I have made. Mariam, tell me the equation for this first one. 5 kg event. Yes? Okay, which direction do we assume to be positive, Mariam?
The up.
Why? Why up?
Because
It's correct. In this case, it will up will be positive. Reason? See, if you can guess it from the figure, acceleration. Okay, direction of acceleration is always taken positive. So see, what is force? Force is equal to mass into acceleration, right, Mariam?
yes, miss.
So what will be the net force here? It can be, see, two forces are acting. Which two forces are acting in this, Mariam, in this body?
Upward and downward force.
Yeah, tension and 5G are acting. Now, net force means two forces
50
are in opposite direction. 50G, 5G, that is 50. You're right. This is 50 and this will be 100 Newton. Okay, so 50 Newton, that is 5G, and this tension, they are acting. Two forces are
Ma'am,
in
why is it 100 Newton here?
100 Newton here for this.
Yes, ma'am.
Multiplied with 10.
Okay, so it's being doubled.
Not doubled. See, doubled will be 20, no? This is getting 10 times bigger. That is just acceleration due to gravity. Precisely, you shouldn't even multiply it with 9. You should multiply it with 9.8 meter per second square. Okay. For the class calculations, I have taken it as 10. But I tell you, and I have been telling you in laws of motion also, that always take 9.8 unless stated. Like in this question, nothing has been stated. So if this was a question from your exams, you should have taken 9.8 meter per second square. Okay. So here 50 Newton, and is that clear, Daura? Why we are multiplying, making it 100?
Yes, ma'am.
Okay. Yes, Mariam. See, Mariam, look at this. You have a 5 kg figure. Tension is acting upwards, 50 Newton is acting downwards. The net force could be T minus 50 or 50 minus T.
50 minus T.
Okay, why 50 minus T here, Mariam?
Because it will be mass minus tension. No.
See, net force is equal to mass into acceleration. This is the Newton's second law. We all have studied. First, tell me what is mass here. What is the mass here, Maria?
5 gram.
kg.
Oh, 5 kilograms, sorry.
हाँ, g means acceleration due to gravity. ग्राम वाला नहीं है, ठीक है? So this is 5. Okay, acceleration is a. Is this clear? This part of the equation will be 5 into a, right? ma 5a. Is this 5? The RHS part, Mariam?
Yeah.
Okay. Now, when we talk about the net force means you are writing the resultant force which is acting. Okay. Now, how will you write the resultant force? Two forces are acting in opposite direction. One above, other below. Right? So, tension is there. Downward force is 50. Now, it could either be T minus 50 or 50 minus T. These are the two possibilities. Right? T
Yeah.
minus 50 and 50 minus T. Now, what did we talk before? The direction of acceleration is positive. I said, no, your answer that upwards will be positive in this case will be correct because you didn't know the reason, but your answer was right. Reason is that whatever is the direction of acceleration, that will be positive. Now tell me which force among these is pointing towards the acceleration. Which force is pointing towards the acceleration on these?
Towards acceleration.
Yes.
The up one.
Yes. Which is? Which force is this?
5 kg.
Which force is this? What is this force called?
Or tension.
Tension. है ना? Acceleration is up. So we will see which force is acting in the direction of acceleration. Acceleration up. So we'll check is tension acting up or 50 Newton acting up. Definitely tension is acting up. So tension
Yeah.
will be positive. This will be negative. So will it be T minus 50 or 50 minus T?
T minus 50 for up and 50.
No, Mariam. See, only T minus 50. Downwards is what? Nothing is here downwards. Acceleration is up. No, only we are just solving this branch of the fire. This will be T minus 50. That's the first equation. Now, Mariam, try for the second one. If you have you understood the first one properly? Why is it written like this?
Yeah.
Now try for the second, this branch. It will give me an idea if you understood or not.
It will be 10A.
This will be equal to 10A, correct?
So 100 minus T equal to 10A.
Yes, perfect. Got it? Because acceleration is downward. So this time 100 Newton will be positive. Okay?
Yeah.
Now clear? Good. Now see class. What we do, whatever we have already studied about these forces, we'll be applying the concept of laws of motion. We'll frame our equations and I hope it's clear to others also, those who haven't understood. So let me write it as minus t plus 100. Let me just reverse it. Minus t plus 100. It's the same thing. Why have I written it like this? So that I can solve it here only. Let's add them because when you add them, tension will be cancelled. 100 minus 50 is 50. 10 plus 5 will be 15a. Acceleration will be 50 divided by 15. This will be 10 by 3 meter per second square. This is the acceleration. Okay. This much portion we have already done in laws of motion class. We have done it in detail in laws of motion. So please, those who still do not know this whole part, as I told you, your mechanics is entirely connected to each other. And not only mechanics, these things will come in your class 12th also. Even though mechanics is not there in your class 12, still all the equations, kinematic equations, the motion under gravity part, the sign convention part, everything is repeated in class 12. Your vectors come as it is in class 12, the integration, differentiation, all these things are there in class 12. And not direct topics. They'll be hidden in the questions. You'll be required to use all these. So 11th class is your basics. Please make it very strong. These kind of questions, like such easy pulley based problems, should be solved by all of you. And if you're still not able to solve, so that's not a big problem because it can be solved. At least start practicing, and wherever you face trouble, get your doubts clarified. Very few students submit the homework. Sanidhi from this batch is very regular with the homework. Nabiha is very regular with the homework. Tahura, Mariam, assignments need to be better. Mariam, you submit the assignment. So your assignment has it just needs a little bit more practice and precision. You at least submit. Mariam, you also share the assignments, but just try to make it better. I make the corrections in your assignment. See those? But just to accelerate up the syllabus a bit, I'm not discussing the assignments. I just want to complete this chapter and come to at least gravitation. If your first book will be over, because your fluids, mechanical properties of fluids is a very, very big chapter. That's why I'm not discussing the assignments. So I'm writing the notes in your answer sheets only, assignments only. Tahura, you do not submit the assignment. Please get up with it. I need to see your work. Okay, Tahura?
Yes, ma'am. Actually, I'm not getting time to submit. That's the reason I'm not able to submit, ma'am.
Are you practicing it?
I'm practicing every day, but I'm not able to submit it.
Okay, if you're
Because of
practicing,
time.
then share it. Okay, take some time. It won't take much time. You can just don't. It doesn't have to be very very neat and clear. This is not your test. No, so just take so that I'll also get an idea what you are writing in your notebook. Okay.
Oh, okay, ma'am.
Yes, class, other students also, everybody, please practice. Means laws of motion and all. And wherever you face trouble, let me know. Some Fridays, anywhere you can be connected separately and the topics can be clarified. Like, see, if you do not know laws of motion, this question you can never solve. See, based on rotation, this is a very easy question. If you know this, you calculate the acceleration. How to solve this? One acceleration has to be taken positive, one acceleration has to be taken negative. So your A1 will be equal to plus 10 by 3. A2 will be equal to minus 10 by 3. And 1 will be equal to 5 kg. M2 will be equal to 10 kg. Just to write this, we had to use the concept of laws of motion. And what did we study for acceleration of the center of mass? M1 A1 plus M2 A2 divided by M1 plus M2. This was the formula which we derived. We differentiated velocity, which was obtained by differentiating position. So 5 into 10 by 3 plus 10 into minus 10 by 3 divided by 5 plus 10. So this becomes 50 by 3 minus 100 by 3. Right? This is 50 by 3. This is minus 100 by 3. That will be minus 50 by 3. This will be 15. Right? So this is 5 into 10. This is 5 into 3. So answer is minus 10 by 9 meter per second square is the acceleration of the center of mass. So the question was very easy, formula based question. But see how can it make it trickier? By using the previous concepts. It can make the pulley move, use initial velocity, calculate displacement, anything. In physics, hypothetical questions can be made because these all are the possibilities. So these kinds of questions can come. Okay, then write this first. Is it done, class?
No, ma'am.
Okay, one small easy question. If you have the velocities given, let's say two velocities are there, because velocities based questions can also be there. So here you take the same values. In the sense, same values in the sense ki you keep one direction fixed. Like pick up a sign convention. Whenever the vectors are in different direction, class P, please choose up a sign convention. Let's say this is positive, this is negative. This is positive means I have taken my sign convention is that rightwards will be positive, leftwards will be negative. Okay. M1 will be 2 kg, V1 will be 5 meter per second. Similarly, M2 will be 5 kg, V2 will be minus 2 meter per second. Now, what's the velocity of center of mass? M1 V1 plus M2 V2 divided by M1 plus M2. 2 into 5 plus minus 2 into 5 divided by 5 plus 2. In this case, it will come out to be 0. It can be anything. In this case, it is coming 0. This is not a standardized answer. You can write this later. First, let me just discuss few more points with you. See, now is the topic of conservation of the center of mass. So there are two different kinds of forces, internal forces and external forces. We've already talked about these two, right? Internal forces also we've studied in laws of motion, and external forces. In fact, this got repeated in work, energy, and power also. So here also, see, internal forces are the forces that are applied within the system, and external forces, any force which is out of the system, means coming from the surrounding. We say these are the external forces. Like if this is my system, forces acting within this, these are internal forces. Any force that acts from outside, that will be considered as the external force. Okay. So here also, if you have a system present, system means the part which is under observation. Let's say this is our system. So any force that is acting here, this is the system, and let's say here is the center of mass of the system, and there is internal force acting within the system. Internal forces are acting within the system. Okay, now there are certain external forces which will be outside of our system. So we have external forces, we have internal forces. Now see, center of mass is present here. So look, the center of mass will not be disturbed by the internal forces. All sorts of internal forces can act over here. What can disturb our center of mass? This external force. So till the time this external force is not acting in your system, the center of mass is conserved. As soon as the internal forces, see, internal forces can act anywhere. They won't disturb the center of mass. As soon as the external force comes into your system, your center of mass's position can change. So you just have to see, is there any external force in your system? No, no external force. Center of mass will be conserved. That is what is meant by the conservation of center of mass. Conservation of center of mass. This is what is meant by it. So remember, internal systems, these are internal forces, these are the system of these are within the system of particles. They cannot affect, means they can affect the system of particles, but they cannot affect the center of mass. External forces also act on the system of particles, but they can affect the center of mass. Okay, now one more thing. Acceleration was this m1 plus m1a1 plus m2a2 up till mnth anth. Like this, we practiced a question also with two systems. That pulley question, we use this formula m1a1 plus m2a2 divided by m1 plus m2 because two masses were there, so only two were required. What if you have multiple of them? If you have multiple of masses, then m3, m4, m5, all of these will be required. Okay. Now, if I take this, we know according to the Newton's second law, the net force is equal to mass into acceleration. So, if I talk about the net force of the center of mass, so acceleration of the center of mass will also be considered. Means individually we can say m1 a1 will give you f1 force, right? If I start putting all the values here, so force of the center of mass will be given by, in fact, what you can do, you can multiply this with a also, m also, mass of the system. See, I'll tell you a better method to write this. m1 plus m2 plus m3, all of these m1 plus m2 plus m3 up till mnth, this can be written as capital M. That is total mass of the system. Total mass of the system, capital M. Now, if this is capital M, like if acceleration of center of mass, this is m1a1 plus m2a2 till mnth, anth. Can I write all these masses that I'm writing as capital M? Right? Total mass I've taken as capital M. Now, if I shift this here, this will be M into acceleration of the center of mass into m1a1 plus m2a2 up till mnth anth. What is this? This is the force of the center of mass. This is F1 plus F2 plus F3 till Fnth. So this will be the formula. First tell me, till here have all of you understood everything? Then only I'll proceed further.
Yeah, mom. Yes, mom.
All right. So that question, these theoretical part, right? Then we'll practice a numerical on the conservation of the center of mass. Please start writing from here. Okay, class, let's practice this question. This says a man of mass small m stands on a wooden plank of mass capital M, floating on a river near its bank. The man starts walking on the plank towards the left. Okay, this is the first case. See, this is the plank. This is the reference origin line that we have taken. X equal to 0, so that we can make out the points where the man is with respect to the plank. The length of the plank is L and man is towards the extreme, okay, edge of it. Now man starts moving towards the edge. Okay. So what will happen if the man is walking towards the edge? The plank would automatically shift a little backwards. See, when you jump on a boat, what happens when you actually land on it? The boat actually shifts a bit behind. Same thing will occur with the plank also. What will happen? The plank will be left a little behind, right? Like this. The plank will be shifted a little back, let's say by some distance x. And man has moved towards the edge of the plank. Now the man can't move forward because there's water, okay? So what has happened here? Since there is no external force acted in our system, till yet there is no external force that has acted in the system. So we will say the center of mass will be conserved. So let's calculate the center of mass in the first case. Then we'll calculate the center of mass in the second case. We'll equate it. So in the first case, see, let's say M1 is the man. The mass of the man is small m. One, separation of the man from the origin. That is the complete length of the plank, L. Okay, so first, see, remember the man plus the plank is your system. So think accordingly why external force will be acting, why it will not be acting, or what all are your internal or external forces. Okay. So man who is towards the edge from the origin, we are taking the separation as L. Now coming to plank. Mass of the plank is capital M. And since it's like a rod, center of mass will be lying at the center. So here x2 will be equal to L by 2. So the center of mass's formula is m1 x1 plus m2 x2 divided by m1 plus m2. So the center of mass will be m into L plus ml by 2 divided by small m plus capital M. Let's leave it. Let's come to the second case when the man has shifted towards the edge. Okay, so in this case, in the second case, see, mass of the man is still m, but what's the position of the man? X1. See, from the origin, the man is at a distance of to the plank. Mass of the plank is capital M. Separation of the plank center of mass. See, plank has shifted x. Plank has shifted to some distance x, and the center of mass is L by 2 behind. So total separation from the origin will be x plus L by 2. Right? This will be x plus L by 2. Now, you write the position of center of mass. M1 x1 plus M2 x2 M plus M. So both the center of masses will be the same. Mx plus capital M x plus L by 2 divided by small m plus capital M is equal to, this will be equal to this one, ml plus ml by 2. So small m into L plus capital M into L by 2 divided by small m plus capital M. This bracket will be cancelled. Only this will be left. Let's open it up. So we will get mx plus, when you multiply this inside with this, we'll get mx plus ml by 2 equal to, this is ml plus ml by 2. See, ml by 2 will be cancelled. From here, can be taken common. That will be small m plus capital M is equal to mn. So what's the value of x? ml divided by small m plus capital M. This is the separation to which the Planck has shifted. Is this question clear? Solution is clear to all? Till
Yes,
here?
ma'am. Yeah, ma'am.
Okay. Please write down this one. This is a question from your NCRT. Okay, see, this next is conservation of the momentum of center of mass. So, in, when we say the net momentum will be constant, means the momentum of the center of mass will be equal to individual momentums P1 plus P2 plus P3 up till Pn. Okay, so when we talk about the isolated system means the external forces. So F is equal to rate of change of momentum. If F external is 0, then this rate of change of momentum will be 0. Hence, momentum is constant. Now, a very basic, easy question, and this will complete the entire portion of center of mass in the translation part. Now, from the rotation part, we've already done a major portion of it, and we'll do the kinematics now directly. So, please revise circular motion today, means before tomorrow's class. Now see, there's a car with mass m and a child is there with small m. This says that if the child jumps off the car towards the right with a velocity u, so he is jumping with a velocity u with respect to the ground. Find the velocity of the car after the jump, means car will also recoil backwards. So in this case, momentum will be constant because there is no external momentum, external force acting. External force is 0. So simply m into u will be equal to capital M into v. What's the velocity of the car from here? Mu by capital M. Okay, please write down this portion from here. Now we are left with the kinematics part, this last part that I'll just start with tomorrow. Yes, class, those who have completed, you can leave. Tomorrow we'll continue. So just revise the circular motion and we'll start